Hello everyone, welcome to Encode Decoded. Today we are going to discuss about operators. An operator is a symbol that operates on one or more operands, and an operand is a value or a variable on which we perform the operation. See here 3 plus 2. Here plus is an operator and 3 and 2 are operands. Now types of operators. Here we have arithmetic operator, relational operator, assignment operator, logical operators, membership operators, identity operators, and followed by bitwise operators. Let's start with the arithmetic operators. In that addition. This addition is achieved by using symbol plus. Let's take an example. num1 equals to 6 and num2 equals to 3. Now print the addition of these two numbers. Print of num1 plus num2 and run it. Now we have the output as 9. Let's take another example, that is num1 equals to minus 6 and num2 equals to 3 and print addition of these two numbers and we get minus 3 because minus 6 plus 3 is equals to minus 3, and use the same example but change the sign for num2, 6 and minus 3. 6 minus 3 equals to 3. That's it. And let's try with the floating point number. num1 equals to 6 and num2 equals to 3.0. Hence we got the output as 9.0 because we are dealing with integer number with floating number. So floating number we got. And try with the complex number also. num1 equals to 6 plus 5j and num2 equals to 3. Now add these two numbers. Now we got the output as 9 plus 5j because the real numbers are 6 and 3 getting added and result as 9, and the imaginary numbers as 5, and in second number we don't have any imaginary number, that is 0. 5 plus 0 equals 5j. Let's try with the string input also. Here s1 equals to hello and s2 equals to hi. Now add these two strings, then we got the output like hello hi. And now I just want to add the string with an integer number, that is number 2 plus s2. Hence we got the error like type error. So here we can see the unsupported operand int and string. Now let's start with the subtraction. Here it is done by using minus operator. Let's take an example. num1 equals to 6 and num2 equals to 3. Now I just want to subtract the num2 from num1. Let's print num1 minus num2. Here we got the output like 3. 6 minus 3 equals to 3. And let's take an example. num1 equals to minus 6 and num2 equals to 3. Now I just want to subtract the num2 from num1, right? Minus 6 minus 3, which is nothing but minus 9. And take another example, that is num1 equals to 6 and num2 equals to minus 3. Here 6 minus of minus 3, which is nothing but plus 3, that is 6 plus 3 equals to 9. And take a complex number, that is num1 equals to 6 plus 5j and num2 equals to 3. So here 6 minus 3, which is equal to 3, and 5 minus 0, which is nothing but 5j, that is 3 plus 5j. And another example is here, num1 equals to 6 and num2 equals to 3.0. As we previously discussed that if we are dealing with floating point number with integer, then we got floating point as output. So here 6 minus 3.0 is equals to 3.0. Okay, now let's take input as string, that is s1 equals to hello and s2 equals to hi. Now I just want to subtract the hi from hello. so that I just need to print s1 minus s2. Just run it, and there we can see the type error, that is unsupported operand. That means string to string there is no subtraction here. And let's take another example, that is s1 equals to high and n1 equals to 3. Now I just want to remove the number from string. Is it possible? No. There is type error, that is string to int is also there is no subtraction operation. Now let's go with multiplication. This multiplication operation done by using asterisk symbol. Now let's take an example, that is n1 equals to 6 and n2 equals to 3. Now multiply these two variables, that is n1 into n2. There we got 6 into 3 is equals to 18. Let's take another example, n1 equals to minus 6 and n2 equals to 3. Minus 6 into 3, which is nothing but minus 18, as well as n1 equals to 6 and n2 equals to 3.0, which is floating point. Now 6 into 3.0, which is nothing but 18.0. Here is an example of complex number, that is n1 equals to 6 plus 5j and n2 equals to 3. Now multiply these two numbers. So here 3 into 6 is equals to 18 plus 3 into 5, 15j. There we got the output as 18 plus 15j. The string input s1 equals to hi and s2 equals to hello. Now I just want to multiply these two string inputs. So there we got type error. That means we can't multiply sequence of non-int. That means we can't multiply the two string inputs. Now I just want to multiply the string with integer number, so that s1 equals to high and n1 equals to 3. Now I just wanted to multiply s1 into n1. There we got the output of high as 3 times, because here we are getting string concatenation. So high into 3, so we are getting high as 3 times. Now division. This is done by using forward slash. Let's take an example, n1 equals to 6 and n2 equals to 4. Now n1 divided by n2, so that 6 by 4 is nothing but 1.5. Here we got floating point number as well. That means if the value has decimal part, then we will get. Let's take another example, that is n1 equals to 6.0 and n2 equals to 4. So 6.0 divided by 4 is nothing but 1.5. Now let's deal with the complex number. N1 equals to 6 plus 5j and n2 equals to 4. Now this 6 divided by 4 is 1.5 and 5 divided by 4 is 1.25. As we know that if we are going to divide the string with string, we will got an error. Let's see an example, s1 equals to hi and s2 equals to hello. Let's divide the s1 with s2 and we got the type error. And another example like s1 equals to hi and n2 equals to 4. Here also we will get an error, type error, that is string and int can't perform the division operation also. In Python we have two types of divisions. First one is division. It is done by using forward slash, which will return a float value. And second one is floor division, which is done by using two forward slashes, which returns the value which has no decimal value. Now floor division. It is done by using two forward slashes. Let's take an example, n1 equals to 6 and n2 equals to 4. Now floor divide these two numbers, then we got the output as 1. Let's try with another example. by comparing the division and floor division operators. Let's n1 equals to 6 and n2 equals to 4. The first one is for division and the second one is for floor division, and run this. We will get output like for division the output is 1.5. that means we will get the decimal part also. For floor division it is only the number which ignoring the decimal part. But here if we are going to deal with the floating point number, then you will get the floating point as output. Now modulus. It is done by using the percentage symbol. Let's take an example. n1 equals to 6 and n2 equals to 4. Now n1 modulus n2. Here we will get the output as remainder 6 modulus 4. Then we will get the output as 2. Let's run this and see the output here. Let's take the another example which contains the floating point number. Then we will obviously getting the output as floating point number. Let's take another example which is n1 equals to 4 and n2 equals to 6. Now n1 modulus n2. So that is 4 modulus 6. Here we will get the output as 4 because 6 into 0 equals to 0. So there we will get the output as 4 because that is the remainder in this problem. Now it's time for the exponent. It is done by using the 2 asterisk symbol. Let's take an example. n1 equals to 2 and n2 equals to 4. Here n2 power n1, which is nothing but 4 into 4 is equals to 16, and there we get the output like 16. Try with another example. n1 equals to 3 and n2 equals to 4. Now 4 power 3, which is nothing but 4 into 4 into 4, that is 4 into 4 16, 16 into 4 is equals to 64. Here also we will make use of floating point numbers and we will get output in floating point number. Now the next type of operators are relational operators. We can also call it as comparison operators because here we are going to comparing the values by using these operators. Let's take an example like n1 equal to 6 and n2 equals to 5. Now we are going to compare n1 and n2 by using relational operators. Let's check them with equal. For that, print 6 equal to 5. It will return a true if 6 equal to 5, otherwise it will return false. Let's run this. There we can see the false because 6 is not equal to 5, right? Let's check with these two string objects. Print hi equals to hello. Here also we are getting false because hi and hello are the two different strings. Let's make this as true. For that, print hi equals to hi. Here we get true as the output. Let's make the number 6 equals to 6. It is also written as true. Let's check the condition with a not equal to operator. Here it is the symbol for not equal to. Let's print 6 not equal to 5. As we know that 6 is not equal to 5, then it returns true. And print hi not equal to hello. Here also we know that hi and hello are two different strings. There we got output as true. Next operator is greater than operator. Here it is the symbol for greater than. Print 6 greater than 5. We know that 6 is bigger than 5, then it's written true. Let's take an example on strings. Print hi greater than hello. Here we can see the first letters of two words are H. Those are equal. And the second characters from those two words are different. From one is I and the second one is E. Hence we know that I is greater than E. Hence it is true. Here we need to follow the alphabetical order to compare the two strings. Next, less than operator. Here it is the symbol for less than operator. Let's take an example. Print 6 less than 5. We know that 6 is bigger than 5, but we are here printing 6 less than 5. It is false. And next one, print hi less than hello. As we discussed earlier, the first character from two words are same H, but the second characters are I and E. As we discussed earlier, I is greater than E, but here we are considering I is less than E, so it is false. Similarly, we can check the string by following alphabetical order, like the C less than B and C less than D. Next one is greater than or equal. Here it is the symbol for greater than or equal to. Let's consider an example. Print 4 greater than or equal to 3. Here we need to consider the two things. The number 1 is either greater than or equal to the second number. Here 4 is greater than 3, so satisfied, it returns true. Now here is another example, that is print 4 greater than or equal to 4. 4 greater than 4, it's false, but 4 equal to 4 is a true. Here we get result as true. Similarly, we can check the strings also by using greater than or equal to operator. Now the next operator is less than or equal to. Here it is the symbol for less than or equal to. Similar to greater than or equal to, we need to consider two conditions, that is either less than or equal to. Here is an example. Print 4 less than or equal to 5. 4 is less than 5 or 4 equal to 5. The first condition, 4 is less than 5, satisfied, hence we return true. Similarly, print 5 less than or equal to 4. 5 is not less than 4 and 5 is not equal to 4, hence we return false. We can also go with the string comparisons also. Now it's time for assignment operators. Here we are going to assigning the value to the variable. The first one is simple assign. That means we are just assigning a value to the variable. Here that is num equals to 5. For the variable num, we are assigning a value of 5. Next one is add then assign. Here it is the symbol for add then assign. Initially we have the value of num as 5, so we are going to add 5 to it. Num plus equals to 5 and print num. Let's run this. We are getting 10 because initially we have num as 5 and here num equals to num plus 5. That is nothing but num equals to 5 plus 5 is equals to 10. So here first we are adding the num and 5, then again assigning it to the variable name num. Similarly, subtract then assign. So here it is the symbol for that, and initially we have the num value as 10. Now num minus equals to 3, print num. So 10 minus 3, which is nothing but 7, and then multiply then assign. Here it is the symbol for that. Initially we have num value as 7 and now we are going to multiply with 3, that is num star equal to 3. Here we get the output as 21. 7 into 3, which is nothing but 21. Next one is divide then assign. Here it is the symbol. Initially we have num value as 21 and we are going to divide with 7. So 21 divisible by 7 is nothing but 3.0, because here we are going to divide by using the single slash, right? The next one is floor divide then assign. Here also we are going to divide the number. Now we have the num equals to 21 and dividing with 7. But here we are ignoring the decimal part. That means from the previous example, we are dividing the 21 with 7, we are getting 3.0. But Here also we are dividing the 21 with 7, but we are getting 3 as output. The next one is exponent then assign. Here we are going to make a power to the number. Initially the num value as 3. I just wanted to make a square to it, which is nothing but 3 into 3 is equals to 9. Here we got the output as 9. Finally, modulo then assign. Here it is the symbol. Taking a num as 6. Now I just want to divide the number and assigning the value to the num, so that num modulus equals to 4. So here 6 modulus 4 equals to 2. Here we are getting the remainder as the output, which is nothing but 2. Here the next type of operators are logical operators. Here we are going to make an operation in between two conditions, whether it is true or false. Here it is the truth table for logical AND. Condition 1 and condition 2 and followed by result. If the condition 1 is true and condition 2 is also true, then only the result should be true. Otherwise the result will be false. So here the result is true only when both the conditions are true. Let's take an example. Here we are going to consider two conditions. The first condition is 6 greater than 5 and the second condition is 4 less than 9. The both conditions are true, so the result is true. And the next example is the first condition is 6 greater than 5 and the second condition is 4 greater than 9. Here the first condition is true but the second condition is false. So here we got the output as false. And the next example is the first condition 6 less than 5 is false and then next condition 4 less than 9 is true. So false and true, we got the result as false also. And here the first condition is 6 less than 5, which is false, and the next condition 4 greater than 9, which is also false. So here we written as false. There we can see if the both conditions are true, then only we got the output as true, otherwise we got output as false. Here we can see if the two conditions are true, then only we will get output as true, otherwise we will get output as false. Now the next one is logical OR. Here it is the truth table for logical OR. Condition 1, condition 2 and followed by result. Here also we will see if the both two conditions are true, then we will get output as true. And if the one condition is also true, then we will get output as true. So here we can understand that if the both conditions are false, then only we will get output as false, otherwise we will get true. If the one condition is satisfied, then we will get output as true. Let's take an example. Here also we are going to consider two conditions. The first one is 6 greater than 5, which is nothing but true, and next one is 4 less than 9. It is also true, then we will get output as true. The next one is the first condition 6 greater than 5. Here it is true, and the 4 greater than 9, here it is false. But here one condition is satisfied, then we will get output as true. Then next example is 6 less than 5 and 4 less than 9. Here 6 less than 5, the first condition is false, but the second condition 4 less than 9 is satisfied. Here we will also get the output as true. And then the condition 1, 6 less than 5 or 4 greater than 9. Here the first condition is false. Similarly, the second condition is also false. So here we will get output as false. So that here we need to know if the both conditions are false, then only we will get false. If the one condition is satisfied, then we will get output as true. Now the next one is logical NOT. Here we are using the NOT. That means if the condition is true, then it will return false when we are using NOT operator. And if condition is false, when we are using NOT operator, then we will get output as true. Here print NOT 4 less than 9. That means 4 less than 9 is true. So but we are using NOT operator, hence we will get output as false. Then the next one is print NOT 4 greater than 9. Here the condition is false, but we are using NOT operator, so NOT false equals to true. Now the next type of operators are membership operators. Here we are going to check whether the value is present in the list, string, tuple, whatever it may be. We are going to check whether it is in or not. It will return true if the value is present. Let's take an example. Here I am going to consider string value, that is s equals to hello. Now I just want to check whether small g is present in a variable s or not. For that, print e in s. So here we can get true because the letter e is presented in variable s. Now let's take another example, that is s equals to hello, and I just want to check whether the letter I is present in s or not. Here we can get output as false because the letter I is not there in s. And the next example is s equals to hello and print small h in s. Here we can get output as false because it is case sensitive. In variable s we have the letter h, but it is capital, but here it is small case. Here we can also check the sequence of characters also. We can check the letters or numbers which are presented in a sequence of characters or a list or a tuple. Here it is an example for list l equals to 1, 2, 3, letter a. Here I just want to check the number 1 whether it is present or not in list L, and similarly I just want to check letter A, whether it is presented in list L or not. And the second one is not in operator. It will return true if the element if the value is not presented in the object or a variable. Let's take an example, s equals to hello and print e not in s. It return false because the letter e is presented in variable s. Let's check with another example, the I not in s. Yes, it will return true because the letter I is not there in variable s. Similarly, we can make use of this not in operator in list, tuple, dictionary, as well as in string also. Now the next type of operators are identity operators. Here we are going to check the number or string whether both are same or not. The first one is operator. Let's take an example, n1 equals to 3 and n2 equals to 4. Now let's check whether the n1 is n2 or not. For that, print n1 is n2. Let's run this. We get a output like false because n1 equals to 3 and n2 equals to 4. Both are different. Let's try with another example, n1 equals to 3 and n2 equals to 3. Now let's check 3 is 3 or not. Here both n1 and n2 are the same integer type and both are stored in one location. So hence it returns true. Let's go with the another example. Here n1 equals to 3.0 and n2 equals to 3. Now I just want to check in two different ways. For that, print n1 equals to n2 and print n1 is n2. Here the first print statement equal by using equal operator, we are going to check whether the values are equal or not. In the second print statement, we are going to check whether the addresses of two numbers are equal or not, so that in output we will get true and false, because for the first one, the 3.0 and 3, the values are equal. For the second one, n1 and n2, both are stored in different locations. First one is float and next one is int, so that we will get output as false. So here we are going to check two lists. So here the lists are same with same elements and same length, but we are getting false because they were stored in different locations. Let's take an example. n1 equals to 3 and n2 equals to 3.0. I just want to print the location also. For that I will make use of id of n1 and id of n2. Let's run this. We will get output as n1 as 3 and n2 as 3.0. But here we got the locations are different. This is the main reason we are getting false as output, even the values are same or equal. And this time n1 equals to 3 as well as n2 equals to 3. So here I will make use of id for know the location. Let's run this. Here we got the output as 3 and locations are also same, because the both variables n1 and n2 are integer numbers at the same time, same value. So it will assign same location for both the two variables n1 and n2. Then the second operator is not. This is the opposite of is operator, because if the values are different, then only we will get true. Here also we can check integer with floating point number, as well as we will make use of lists to compare whether the two lists are not equal or equal. Now the next type of operators are bitwise operators. These operators are going to deal with the binary digits, which are 0 and 1. This is the truth table for bitwise AND. Here we can see if the both bits are 1, then only we can get output as 1. Otherwise, it results as 0. Let's take an example. Here n1 equals to 7 and n2 equals to 4. So binary number of 7 is 0, 1, 1 and 1. And the binary number of 4 is 0, 1, 0 and 0. So I just want to make a bitwise AND operation in between the two numbers n1 and n2. That is 7 bitwise AND 4. So here we are going to make operations in between binary digits, which are zeros and ones. Here 0 and 0 is 0, and 1 and 1 is 1, and 1 and 0 is also 0, and 1 and 0 is also 0. So we know that when the two bits are ones, then only we will get result as 1. So here it is the output of binary number 7 and 4, 0, 1, 0, 0. This is equal to decimal number 4. Let's run this and see the output as 4. Let's take another example. This time n1 equals to 8 and n2 equals to 3. These are the binary bits for 8 and this is the binary digit for 3. Now make operation between n1 and n2, which is nothing but 8 and 3. So here we got the output as 4 zeros, which is equal to the decimal number 0. Hence run this and see the output as 0. The next one is bitwise OR. See here, we will get result as 0 only when if the 2 bits have the value as 0. Otherwise, we will get result as 1. That means if any one bit has a value as 1, we will get output as 1. Let's take an example, that is n1 equals to 7 and n2 equals to 4. Here these are the binary numbers for 7 and follows 0, 1, 1 and 1 and 0, 1, 0, 0. So here we are going to make operation on these two numbers, n1 bitwise OR n2, that is 7 or 4. And we know that if the 2 bits are 0, then only we will return as 0. So here 0, 1, 1, 1, which is nothing but 7. Hence run this and see the output as 7. Let's try with the another example, that is n1 equals to 5 and n2 equals to 13. Here are the binary numbers of 5 and 13, and this is the output after we performing the bitwise OR operation in between 5 and 13. So 1, 1, 0, 1 is equals to 13. Let's run this and see the output as 13. Now the next one is bitwise XOR. Here we can see if the 2 bits are equal, that means if the 2 bits are same, then we will get output as 0. Or if the 2 bits are different, then we will get output as 1. Let's take an example, n1 equals to 7 and n2 equals to 4. These are the binary numbers of 7 and 4. Now we are going to make an operation of bitwise XOR in between 7 and 4. So after performing the bitwise XOR in between 7 and 4, we will get output as 0, 0, 1 and 1, which is equal to the decimal number 3. Here is another example, that is n1 equals to 5 and n2 equals to 14. Here are the binary numbers for 5 and 14, and 5 bitwise XOR 14. That means we will get result as 1, 0, 1 and 1, which is equal to the number 11. Let's run this and see the output as 11. And the next operator is complement operator. This is simple operator. Let's take an number and find its binary number and add 1 to its end. Then we will get complement for the number. Let's take an example. Num equals to 5 here. So the binary number for 5 is 0, 1, 0 followed by 1. Now let's simply add 1 at the end. That means 1 here, and now let's add this 1 and get the output like 1 plus 1, which is nothing but 0, and 1 is carried to here and 1. Now 0 plus 1 is 1, and here 1 is and 1 same here, and 0 is same here. Now we have the output after performing the complement like 0, 1, 1 and 0. Here we will get the value as 6 and change the sign to its, that is nothing but -6. Let's run this and see the output as -6. Now let's take another example, that is num equals to 7. Here it is the binary number for 7 is 0, 1, 1 followed by 1. Now just simply add 1 at the end. So here 1 plus 1 is equals to 0 and carried 1 to here, and now again 1 plus 1 is 0 and carry that 1 is to here, and again 1 plus 1 is 0 and carry the 1 to here. Now 0 plus 1 is equals to 1. Now we have the binary number as 1, 0, 0 and followed by 0, which is equals to the number 8. Now change the sign to its -8. Let's run this and see the output as -8. Now the next operator is left shift operator. So here we are going to add zeros to the right side of the number. Here it is the syntax for left shift operator, that is number, left shift operator and shift count. How many times we need to shift the digit. Let's take an example, that is print 4 left shift count, that is 2. So 4 left shift 2, we need to shift 2 times here. We know that binary number of 4 is 0, 1, 0, 0. And for first iteration, we need to add 1 0 to it. So 0, 1, 0, 0, 0. And for the second iteration, again we need to add 1 more 0 to it. 0, 1, 0, 0, 0 followed by 0. This is equal to the number 16. Let's run this and see the output as 16 here. Let's take another example. 4 left shift 3. I'm using shift count as 3 here. So we need to iterate this 3 times. That means we need to add 3 zeros to the right side. And for the final output we have 0, 1, 0, 0, 0, 0 and followed by 0, which is nothing but 32. Let's run this and see the output as 32 here. So here we need to consider the shift count as positive integer value. Let's check with this negative integer. Let's run this and see the output as value error, negative shift count. So we need to mention only the positive integer. What if we are using the shift count as floating point number? Let's make use of it and see the output as same again. Type error, unsupported operand, int and float. And it can't be complex number also. We just need to make a positive integer value for a shift count. Now the right shift operator. Here it is the syntax for right shift operator, number, right shift count. In right shift operator, we are going to add 1 0 to the left side. At the same time, we are eliminating the last digit on right side. So let's take an example here. Print 4 right shift 2. As we know that the binary number of 4 is 0, 1, 0 followed by 0. And we are making right shift operation here. So here we are adding 1 0 to the left side. At the same time, we are eliminating the last digit at the left side end. So that we have 0, 0, 1, 0 at first iteration. Now for the second iteration, 0, 0, 0 followed by 1, which is equals to the value 1. Let's run this and see the output as 1 here. Let's take number as 7 and shift count as 2. We know that binary digit for 7 is 0, 1 and forward by 1. For a first iteration it is 0, 0, 1 and 1. And for the second iteration it is 0, 0, 0 and 1, which is equal to the 1 again. And let's increase the shift count to 3. So for the first iteration it is 0, 0, 1, 1. For the second iteration it is 0, 0, 0 and 1. For the third iteration 0, 0, 0 followed by 0, which is equal to the value 0. Let's run this and see the output as 0 here. In right shift operation also we can't make use of the negative shift count and the floating point shift count and the complex number shift count. We just maintain the shift count as positive integer value